All right, so far we've talked about ocean currents, which we know is kind of like a highway in the middle of an ocean. And we know that our ocean currents are going to transport thermal energy, and it's going to transport nutrients, and it could also be a mode of transportation for a lot of sea life. Now, in terms of our surface currents, when we were observing them, when we were modeling them, we saw that the wind dictates how the surface currents are going to move. So those currents will move in the direction of the wind. We also know that our surface currents do transport heat energy from your equatorial warm region up to your polar regions, and then back down to the from cold to warm areas again. But we talked now a little bit about these density currents. So talking about ocean currents that are further deep in our ocean. So we're going to model the two effects that really do impact a deep ocean current. The first one that we're going to look at is temperature, which we all know temperature is very, very straightforward. So what we have today, and I foresaw this when we did the convection lab with Earth's mantle. I told you that that lab was going to come back around to us. So we're going to kind of model it ocean style now. All right, guys. So I have my pan of water right here. Okay. So a couple of things. So this is a very straightforward lab, but there are a lot of observations that you will have to make, and you will also have to sketch out what we see. So please make sure you are paying very, very close attention to it. So I have my bin of just plain old tap water. This might work. Okay. All right. I filled a beaker with ice cold water. And I'm going to fill another beaker with extremely hot water. Okay. Okay, so here is my beaker of hot water. All right, so I also have red and blue food coloring. So the first thing that we're going to do is we're going to put 4 drops of the blue food coloring around my cold water. Okay. The next thing, so notice that it's sinking to the bottom. That is key right there. Then I'm going to take my red and I'm going to put 4 squirts around my hot water. And now we're just going to make some observations. The first thing that I want you to do is write down some observations. And this is what I want you to sketch this out too, guys. So I want you to take, this is your side view, but I also want you to take a top view of what is going on. Okay. And this is exactly what is happening in our ocean as we speak. So you're going to think about what is actually causing these ocean movements. And I want you to include the concept of density. So what is happening as, you know, these currents are moving from a hot source to a cold source? You can definitely see, like, definitely take a look at that of that side view too, guys. And look again at the top view. It really does. This is one of my favorite labs to do as well. But the side view is really, really cool. But one thing that you definitely probably notice is as soon as I put the blue dye around my cold water source, it immediately sank, while my red dye did the opposite and started to rise. But the kicker is, look how they are traveling. So I have hot water on here, cold water right here. I want you to also think about, and these are some of the analysis questions that you're going to be answering for this section alone. I want you to describe some factors that could cause ocean water to be warm or cold or cool. Cold or cool, doesn't matter. Think about where you would already find the ocean water that is relatively warm or relatively cold. And something else that I want you to think about is if this pan, if I left this out overnight, would the water still be moving tomorrow? Just like how we're looking at it right now, where we have the red traveling and the blue traveling at the bottom, and your red is at the top, which you can definitely see. I'm going to try to get this down a little bit, guys, so you can see a side view too. There we go. So you should be able to see that side view too. So that could be included in your sketch too, guys. But notice how you have the red at the top, the blue is at the bottom. You have some red at the bottom, but mostly the red is at the top. So think about that. But if we were to keep this pan out overnight, would this still look like what it looks like now? Would the water still be moving? Or do you expect the ocean current in our model to stop? And to piggyback off that, can you expect real ocean currents to stop? And explain why you think they may or may not stop. All right, guys. Well, I hope you enjoyed this lab. Tomorrow, the second half of this lab is now going to examine salinity. So think about first, review what salinity is and how can salt now impact our density currents in our ocean. Temperature was one, salinity was the second. So how exactly does salinity play a role in deep ocean currents? All right, guys, so make sure you pay very close attention. Make some awesome observations, both from a top view as well as a side view. So please keep that in mind. I did give you a top view a couple of times. I also gave you a side view. So please make sure that you are sketching both of them. And if you are doing this at home, please make sure you put your sketches on a separate sheet of paper and you upload them to Google Classroom. All right, guys. Next video will be posted when we do our salinity portion. Have a good one, guys.